Last night on the homework you might have had some questions, and so I want to go through them. One of the biggest questions is like this: b equals 8/7 times the quantity j minus 18. A lot of people want to distribute it, but since we're solving for j, it's actually easier to multiply both sides by the reciprocal 7/8. Then I have 7/8 b equals j minus 18. Now to get j by itself, all I have to do is add 18 to both sides, and I have the answer 7/8 b plus 18. So if you have a variable you're solving for and it's only in the parentheses, or if it's only out of the parentheses, you don't need to distribute. Another question was this: a blueprint of a concrete patio has a scale of 2 inches equals 3 feet. So the first thing you can do is convert the blueprint to the actual size by multiplying by 3/2. This gives you 15 feet by 12 feet. Now you want to put it in the new ratio. The new ratio is here, 4 inches equals 5 feet. And so if I multiply everything by 4/5, I get the 15 feet turns into 12 inches, and the 12 feet turns into 9.6 inches. Today's lesson is ratio, rates, and conversions. This should be a review, except for the unit analysis might be new to some of you. The first question: 2 Olympic athletes can run the races in the time shown below. Who is the fastest runner? How do you know? You can stop the video, figure it out, and then see if you're right. Okay, the correct answer is athlete A. And you can do meters divided by seconds to see which one has the faster, who can run more meters in a second. A ratio compares two numbers by division. There's 3 ways of doing that. There's A over B, there's A to B, or there's A to B. The colon represents A to B. A ratio that compares quantities measured in different units is called a rate. So ratios have the same unit, rates have different unit. We're going to deal with rates today. A rate with a denominator of 1 is called a unit rate, which we use all the time. Price per can, price per gallon. Here we're shopping for t-shirts. Which store offers the best deal? Well, store A is cost per shirt is 25 divided by 2. Store B, cost per shirt, $45 divided by 4. Store C, cost per shirt, $31 divided by 3. And so the first one's $12.50. The second one is $11.25. The third one is $10.33. So store C has the best deal. A conversion factor is a ratio of 2 equivalent measures in different units. We're going to use some conversion factors today. So it says, what is the given amount converted to the given unit? So if I want to change 330 minutes to hours, a lot of you are used to just dividing by 60. Well, if I use a conversion rate, it would look like this. I take 330 minutes over 1, and I always multiply it by some rate. There's 1 hour in 60 minutes. And it's chosen this way because then minutes are in the numerator and the denominator, so they will cancel. And when you do that, you get 330 over 60, which then reduces to 5.5. Here we're changing kilograms to grams. Many of you know just to move the decimal point. That's a fine method, but if I want to use a conversion rate, I can say 15 kilograms over 1, and I multiply it by another rate. This time 1,000 grams is the same as 1 kilogram, and I put kilograms on the denominator because I want the kilograms to cancel out and just leave grams. And I get 15,000 grams. Next, 5 feet 3 inches to inches. We know we just take feet times 12. Well, again, using a conversion rate, I can do 5 feet over 1 times 12 inches over 1 foot, because 12 inches is the same as 1 foot. And then I'm going to add the 3 inches. When I do that, I get 63 inches. So the conversion rate is the process that we're trying to practice today. What is 1,250 centimeters converted to meters? Again, I have 1,200 centimeters over 1, and I multiply that by 1 meter per 100 centimeters. So I have centimeters in the numerator and denominator. They will cancel, and I'm left with 1,250 over 100, which reduces to 12.5 meters. The process of including the units for each quantity in the calculations to help determine the units is called a unit analysis. Using these conversion factors is unit analysis. This is an extremely important concept for chemistry and other science classes. It's also helpful if you don't know what unit the answer should be in. The CN Tower in Toronto is about 1,815 feet tall, and I want to convert it to meters. There's 1 meter is about 3.28 feet. Again, I'm going to use a conversion factor. I take 1815 over 1, and I multiply it by 1 meter per 3.28 feet. The feet in the numerator and feet in the denominator will cancel, and I have 1815 over 3.28. I divide and get 553 meters. Here's an instance where we probably would use a calculator. I hear you all applauding. Monetary exchange rates change from day to day. The day I took this one, 1 euro equaled 1.3 US dollars, or 1 US dollar equaled 0.77 euro. About how many euros could you get for $325 for the exchange rate shown? So again, a conversion rate. I'm going to do $325 over 1, and I'm going to multiply it by 1 euro per $1.3. I get 325 over 1.30. Doing the division, that comes out to 250 and a quarter euros. A student ran the 50-yard dash in 5.8 seconds. This is a really fast student. At what speed did the student run in miles per hour? Now this, I have two different units in my original. I have 50 yards per 5.8 seconds. So I'm going to start with that, and I'm going to need several conversion rates. 50 yards per 5.8 seconds. Well, to change the seconds to hours, I put 3,600 seconds in an hour. And if you don't know that, it's just 60 minutes in an hour, 60 seconds in a minute. 60 times 60 is 3,600. So now the seconds will cancel, and I'm left in yards per hour. But I need to change it to feet. So I say 3 feet, actually miles, but I don't know the conversion in yards. So I change it to feet. 3 feet per 1 yard. The yards will cancel, and now I'm in feet per hour. And I do know there's 5,280 feet in a mile. Here I put feet in the denominator to cancel with the 3 feet in the numerator, and I'm left with miles. And so once I multiply all the numerators and multiply all the denominators and then divide, I'll get miles per hour. In this case, 17.6 miles per hour. Another athlete ran a sprint of 100 feet in 3.1 seconds. At what speed was the athlete running in miles per hour? I'm going to do the same thing. I'm going to start with 100 feet per 3.1 seconds. This time, there's 1 mile is 5,280 feet. Notice the feet in the numerator and denominator, and 3,600 seconds in an hour, so that I have seconds in the numerator and seconds in the denominator. When I multiply through and divide, I end up with about 22 miles per hour, which is extremely fast. And that's it. I hope this helps.